Okay, hello students. So in this video, I will show you how to solve integrations using integration by parts technique. Okay, so integration by parts is a technique to solve an integration in the form of product. So product ni maknanya multiplication lah of two functions or two different functions. Okay, such as x square sine 5x dx. So in this question, dia ada dua fungsi yang berlainan. There are two different function, which is x square is a algebraic or polynomial function, and sine 5x is a trigonometric function. Okay, so the main interest in integration by parts is to transform an integral into a new integral that is easier to solve than the original. Okay, so for the integration by parts, there's a formula. Okay, if you can see in the green box here, the formula is integration u dv equals to uv minus integration of v du. Okay, means there's a product of two different functions, right? So you have to choose one function to be u and then another function to be dv. There's a product of two functions, right? Okay, so you have to choose one function to be u, which is then will be differentiate. Okay, and then another function to be dv, which is then we will integrate. Okay, okay, so how to choose which function to be differentiate and which function to be integrate? Okay, so this is the guideline of selecting u. Okay, if you choose one function to be u, then the other function is automatic will be dv. Okay, so you choose u by the following sequence: LATE, let. Okay, let, which is the first one log. Okay, the second one is algebraic function, the third one is trigonometric function, and then the fourth is the exponential function. Okay, so and the next function automatically becomes dv. If the new integral is more difficult than the original, change the choice of u and dv. So first we will look into the sequence, okay, of either it is in between log and algebraic, or algebraic and trigo, or trigo and exponent, or log with exponent. Okay, we will see this example later. Okay, and then whenever the first sequence will be u, okay, and then the latter will be dv. For example, in between log and algebraic, you will use log as your u. In between trigo and algebraic, you will choose algebraic to be u. Okay, and so on. Okay, for example, evaluate x cos x dx, the integration of x cos x dx. Okay, so in this problem we have two different functions, which is x is the algebraic function and cos x is the trigonometric function. Okay, so if you remember the late, the algebraic function comes before the trigonometric function. Okay, so we choose the algebraic as u and then the trigo as dv. Okay, so just remember the LATE. Okay, so let's look into example 1, the integration of x cos x dx. So if you can see here, we have a algebraic function, the function x, and we have a trigonometric function, which is cos x. Okay, so refer to the LATE. So we choose our u as the algebraic function, which is equals to x, and then we choose our dv as a trigonometric function, which is cos x dx. Okay, and then what you have to do is you have to differentiate, and the other one you have to integrate. Okay, so here we differentiate du over dx will have 1, so we have du equals to dx, and here we integrate the dv. Okay, it means we integrate cos x dx, we integrate dv to find v. Okay, so integration of course will have a sign. Okay, so in this part we omit the plus c. Okay, so plug in everything into our formula, which is the u dv equals to uv minus the integration of v du. Okay, so this is our formula of the biparts technique. Okay, so what we have is x cos x dx is equals to uv. Our u is x, our v is sine x, minus the integration of our v again is sine x. Okay, and then our du is our dx. Okay, remember this part we have to integrate again. Okay, so this is not the final answer yet. Okay, so the final answer is x sine x. Okay, minus, so we integrate sine x, we will have a negative cos x, and then we plus c here. Okay, because this is a indefinite integral, so we have to plus c, the constant. So this is our final answer. Negative negative will be positive. Okay, next example 2. So we have the integration of 3x squared ln x over dx. Okay, so our integration here or function here is algebraic function 3x squared and the logarithmic function ln x. So in between log and algebraic, log is chosen to be u. Okay, so let u equals to ln x and dv equals to 3x squared dx. Okay, so differentiate the u, will have 1 over x, so du will be 1 over x dx. Integrate the v dv, so I will have v equals to 3x to the power of 3 over 3, which is x to the power of 3. Okay, and then substitute into the formula of biparts, which is uv. So our u is ln x, v is x to the power of 3 minus the integration of v, which is x to the power of 3, the integration of v du. So our du is 1 over x dx. So x here I can cut up. What I have, what's left is x to the power of 3 ln x, minus x squared dx. Okay, which is this part I still have to integrate, remember. Okay, integrate. So I have x to the power of 3 ln x minus x to the power of 3 over 3, and then remember plus c. Okay, so example 3, we have two different functions. An algebraic function, a polynomial function with exponential function. So remember LATE. Okay, so a algebraic comes before the exponent, so we have to choose u as our algebraic function, which is 2x, and then the dv is the exponential function, exponent x dx. Okay, again differentiate du respect to dx, we will have 2, then the other one we have to integrate. Okay, v equals to exponent x. Okay, and then just substitute back into our formula, which is uv minus the integration of v du. Okay, so our du is equals to 2 dx. So the answer is 2x exponent x. So remember, integrate this one. Okay, the integration will be 2 exponent x as well. Okay, okay, so our next example, example 4, is another case of algebraic with exponent. Okay, so as example before, u is equals to the algebraic function, which is 3x, and we choose dv equals to exponent x, the exponential function. Okay, so u we have to differentiate, then we'll have du equals to 3 dx, and then the dv we have to integrate. So we have v equals to exponent x. Okay, so substitute everything into our formula. Okay, we will have uv 3x exponent x minus the integration of v du, which is 3 dx. Okay, so this 3, okay, you can bring outside the integration, and then remember to integrate this part. So I will have 3x exponent x minus 3 exponent x. Okay, so you don't have to plus c because you have a limit, okay, from 1 to 1.5 that you have to substitute the value. 1 to 1.5. Okay, so I will have 3 times 1.5 exponent 1.5 minus 3 exponent 1.5. Okay, minus, then substitute the value 1. Okay, this one will become 0. So we have 4.5 exponent 1.5 minus 3 exponent 1.5. Okay, which is will be 1.5 exponent 1.5. Okay, so use your calculator, you will find this value, 6.7225. Okay, so our last example in this topic. Okay, example 5. So we have exponent, a product of exponent and trigo. Okay, so using LATE, L-A-T-E, exponent comes after trigo, so we choose the trigonometric, which is cos function, as u. So u equals to cos x, so our dv will be equals to exponent x dx. So differentiate cos, we will have negative sin x, so our du will be negative sin x dx, and then integrate dv, we will have v equals to exponent x. Okay, so v, which is cos x exponent x, minus integration of v exponent x du. Our du is negative sin x dx. Okay, so we'll have exponent x cos x, minus will be plus the integration of exponent x sin x dx. Okay, remember this part we still have to integrate, and as you can see, it is another product of two different functions, which is the exponent and trigo. Now the trigo is sine, no longer cos, so this integration we still have to use by parts technique. Okay, so this is an example of the by parts technique must be applied several times to evaluate a given integral. Okay, let's say take this part only. So again, u is the trigo function, so we choose u as sine now, and then dv is a polynomial function, which is exponent x dx. So we repeat again, du dx now will be cos, and then v will be exponent x. Okay, so substitute to the last integration. Okay, so uv, which is sine x exponent x, minus v du. V du is exponent x cos x dx. Again, remember there's still a integration function, integral that need to be solved. And then the integration is again exponent with trigo. Okay, so it seems to be never-ending calculation in between exponent and trigonometric function, because whenever you integrate exponent, you will have another exponent. Whenever you differentiate a trigo, you will get another trigo. Okay, so how do we solve this one? If you see here, this is the integration of exponent x cos x. This is also the integration of exponent x cos x. Okay, so if I bring my right hand side to left, so I will have exponent x cos x dx. The minus will be plus the another integration of exponent x cos x dx. Okay, what's left on my right is exponent x cos x plus sine x exponent x. Okay, so let me rewrite this so you will never get confused. Exponent x sine x. Okay, actually it's the same thing. Okay, but I want to rewrite in where I bring the exponent to the front. Okay, so the integration here, okay, integration plus another integration which is the same things. So I will have 2 of the integration of exponent x cos x dx. Okay, which is exponent x cos x plus exponent x sine x. So the answer here is the integration of exponent x cos x dx is exponent x cos x plus exponent x sine x. How about these two? Okay, so you move the 2 to right hand side, will have from multiplication it will be a division, and then plus c. Okay, so whenever you have a question or problem, okay, integration problems in terms of exponent and trigo that seems never ending, okay, you use this technique. Okay, you bring the right hand side to left hand side, okay, and then you solve it. I finished with this video on integration by parts. Okay, so next video will be integration by partial fractions. Okay, so you can start do the exercises on integration by parts, and if you have problems you can contact your lecturer. Thank you.